In this video, we'll solve linear and compound inequalities, and we will graph them and write a solution in interval notation. So let's start with some linear inequalities like these 5 examples. Let's solve example 1. 3x minus 5 greater than negative 17. So to solve this, we are solving them the same way we solve equations. We isolate the variable, so we add 5 to both sides, and we get 3x greater than negative 12. We keep the inequality sign, we divide by 3 to find x, and x is greater than negative 4. So we solve this. Now to graph it, we would draw the number line, negative infinity, positive infinity. We plot negative 4, and we shade all the points that are greater than negative 4, which is this. It's all the area to the right. Or you can think like this. If I put a line here, it's x, it's pointing to the right. So that's why I go to the right of negative 4. So then we graphed it. And now write in interval notation. Well, because the symbol is strictly greater than, that means we will put parentheses. So interval is negative 4 to infinity, parentheses on both sides. At infinity we always put parentheses, but in this case we put parentheses because a symbol like this means parentheses, a symbol like this one means parentheses, greater than or equal to means bracket, less than or equal to means bracket. Sometimes they use circles to represent strictly greater than or less than, and closed dots to represent greater than or equal to or less than or equal to. Let's solve problem 2. Negative 2x minus 4 greater than x plus 5. So I'm going to move the x on this side, and I'm going to move the negative 4 on this side. So to do that, we will subtract x from both sides, and we will add 4 to both sides. So we get negative 2x minus x is negative 3x, negative 4 plus 4 is 0, greater than negative x plus x is 0, and 5 plus 4 is 9. We divide by negative 3 both sides, and we get x less than negative 3. So when we divide by a negative number, we have to switch the sign of the inequality. And let me explain why. For example, if you have 2 is less than 4, we all agree with that. If I divide by negative 2 both numbers, I get negative 1 compared with negative 2. But I know that negative 1 is greater than negative 2. So in order for the inequality to stay true and correct, then we have to switch the sign of the inequality. So going back to our problem, we got x less than negative 3. That's solving the inequality. Now let's graph it. Negative infinity, positive infinity, plot negative 3, and less than, or if you think about the arrow is going to the left, I'm going to shade this region because it's strictly less than. We're going to put parentheses. So in interval notation, all the numbers that are less than negative 3 are from negative infinity to negative 3, parentheses on both sides. We always write the interval looking at the end values of the region that we shade. Let's solve problem 4. So x greater than x plus 1. Again, I want to move x on this side, so I subtract x from both sides. And x minus x, so x minus x, it's 0. X minus x is 0, so on the left side I have 0, greater than x minus x is 0 plus 1, 1. Now 0 greater than 1, that's false. So what does that mean? It means no solution. There is no real number that replaced in instead of x to get something true. So that means empty set, or we can, when we draw the number line. We don't shade anything, so there is no solution. And let's look at 5 now. X less than x plus 1. Again, we subtract x from both sides. X minus x is 0, less than 1. This is true all the time. So what does that mean? It means when I draw the number line, negative infinity to infinity, no matter what number I pick from here, this inequality is going to stay true. So just imagine, if we pick 5, 5 less than 6, it's true. How about 0.1? 0.1 less than 1.1, true. How about negative 7? Negative 7 less than negative 6, true. So all the numbers that we choose are solutions. So I'm going to shade everything. And so this would be the graph. And in interval notation, we would write the solution as negative infinity, positive infinity. We always use parentheses to reflect that endpoint at infinity. Let's solve an application problem. Let's say you want to find the final exam grade given that the weights are for homework 20%, for quiz 10%, for attendance 10%, for exams 30%, and final exam 30%. And the grades are 70 for homework, so all your homeworks together divided by how many you have, average to 70. For quizzes, you got 60. For attendance, you got 100%. For exams, or you had a few exams, if you add all of them up and divide by how many you have an average of 70. And the question is, what should you get for final exam to get at least 80 for the course? So how do we do that? Well, 20% of 70, so we do 0.2 times 70 plus 10% of 60, so that would be 0.1 times 60 plus 10% of 100, so that's 0.1 times 100 plus 30% of 70, so that's 0.3 times 70 plus final exam is 30%, so 0.3 times x, because I don't know the grade for final exam, I want to find it, to get at least, so at least means greater than or equal to 80. So at least 80 means you want 80, 81, 82, and so on. So let's solve this linear inequality. Now if we compute this, we get 14, plus if we compute this, we get 6, plus if we compute this, we get 10, plus 21, plus 0.3x greater than or equal to 80. So what I'm going to do next is add these numbers up on the left side. So 20, 30, 51. So 51 plus 0.3x greater than or equal to 80. And we subtract 51 from both sides. 0.3x greater than or equal to 29. Divide by 0.3 on both sides. And we get x greater than or equal to 96.7. So in order for you to get at least an 80 for the course, you have to get at least a 96.7 for the final exam. So if you get exactly 96.7, you're going to get exactly 80 for the course. And if this is how, doing this example, you are actually learning how to calculate your final grade, looking at different scenarios for a course with that has the final grade weighted. Now let's solve a few compound inequalities. So what does it make compound inequality? Well, let's take a look at this example where we have to solve graph right in interval notation. So if we take a look at the first problem, it has x minus 3 less than 5 and 2x plus 4 less than 14. and it's connected with the word and between them. So that makes it compound because it has two inequalities connected with the word between them. This one, again, it's a compound one because it has two inequalities, but it has the word and. This one, again, it has two inequalities, but it uses the word or. And this one, it's a little bit different than the other ones because it doesn't have the word and or between them, but what it actually means is 2x plus 1 greater than negative 3 and 2x plus 1 less than or equal to 3. So it is actually an word and between them, but it's implied. We usually read this type of inequality as 2x plus 1 is between negative 3 and 3. All right, so let's solve some of them. So let's solve the first one. How do we solve it? Well, we solve each of the inequalities individually. So I'm going to add 3 to both sides, and we get x less than 8, so that's pretty much it. And let's solve the other one. We subtract 4 from both sides, we get 2x less than 10, we divide by 2 both sides, and we get x less than 5. So we got x less than 8 and x less than 5. So we calculated, now let's graph. So we graph it on the same number line, we put both inequalities. So x less than 8, I'm going to plot 8 and 5 in the order that they are on the number line. So now x less than 8 means I'm going to shade all the points that are less than 8 and I'm going to put parentheses. And let's do with blue the second one, x less than 5. So we shade up to 5 and we put parentheses. So because they use the word and, we are looking for overlap. So when we see the word and, where x is less than 8 and is less than 5, well, if we look at where the black and blue overlap is between negative infinity to 5. And this is final answer in interval notation. Now let's try to solve problem 4. This one is a little bit different than the other one because it has the word or. So if and was where they overlap, or means everything. So we'll look for that. So now we add 3 to both sides and we get 2x less than 10. We divide by 2 and we get x less than 5. Or, let's see what the other produces. Subtract 35 from both sides. Negative 4x less than or equal to negative 32. Divide by negative 4. And x is greater than or equal to, remember when we divide by a negative number, we flip the sign of the inequality. So x greater than or equal to 8. Let's plot this on the number line, and we have 5 and 8. We put them in order. X less than 5 means I'm going to shade all these and put parentheses at 5. And greater than or equal to 8 means go this way and put bracket because it was greater than or equal to. So now, because it says or, and I want everything that is shaded, then the interval is going to be negative infinity 5. So I read these numbers from left to right, and the endpoints are negative infinity to 5. Instead of the word or, I'm going to use this union sign that we talked about in a previous video. And then the other endpoints of the interval are h to infinity. So if I pick a number from this interval, so if, for example, I pick 0, and I replace 0 in the two equations, I get 0 minus in these equations. I get 0 minus 3, that's negative 3 is less than 7. That's true. Or the other one to be true. So, or 35 less than or equal to 3, which is this is false, but I have this one or the other one. So one of them works, right? Like, for example, if you say I work Friday or Saturday, it means you work on Friday or you work Saturday. One or the other one, not both, right? For both, you would have and. Okay, and let's take a look at another one from here. How about the fifth one? So 3x minus 5 less than or equal to 13, or 5x plus 27 greater than negative 3. So I add 5 to both sides, and I get 3x less than or equal to 18, divide by 3, and we get x less than or equal to 6. Or, and let's work on the other one, minus 27, 5x greater than negative 30, divide by 5, x greater than negative 6. So now let's graph it. Negative 6 would come first and 6 next. X less than or equal to 6 means shade everything from to the left of 6 and put parentheses because of this sign less than or equal to. And then greater than negative 6, but it's strictly greater. So I'm going to use red, which means from negative 6, greater values are like this. Because it's or, and we said when it's or, it means everything that is shaded. So if I take a look at this graph, I see that everything from negative infinity to infinity is shaded. So the solution is negative infinity to infinity, or all real numbers are solutions, because any number you replace is going to satisfy one equation or the other one, or both equations. And let's also solve problem 3, because it's a little bit different than the other ones. It has these symbols together. So 2x plus 1, I changed it a little bit. Originally it was greater than negative 3, but I made it greater than or equal to, just so that we have all symbols or equal to. So what I'm going to do is to get x by itself, right? First to get 2x by itself, I'm going to subtract 1 from all sides. So we get negative 4 less than or equal to x less than or equal to 2. Then I'm going to divide by 2 everything. So I get negative 2 less than or equal to x less than or equal to 1. Or in other words, we can read x is between negative 2 and 1, inclusive, right? Inclusive, the points negative 2 and 1 are inclusive. So if I were to draw that, right, x is between negative 2 and 1, I would put brackets and shade in between, right? Between those. So in interval notation, our final answer would be negative 2 and 1. And let's do one extra problem, because this is interesting. X plus 1 greater than or equal to 3 and negative x plus 9 greater than or equal to 10. So if we solve each of them, we subtract 1 from both sides, x greater than or equal to 2. And, right, the word and, which we should always say, if it's and, then I'm looking for common. Or overlapping. Negative x greater than or equal to 1. Divide by negative 1 and get x less than or equal to negative 1, right? We make sure we switch this sign, right? When we divide by negative number. Now to graph it, number line, and then we put the numbers, so x greater than or equal to 2 and x less than or equal to negative 1, so negative 1 comes first, and then 2. Greater than 2 means we're going to shade to the right of 2 and we put bracket. Less than or equal to negative 1, we put negative 1 and we shade this one. Now, and means overlap. So, are these two, this interval and this interval, overlapping. Do they have anything in common? They don't. So the answer would be empty set, no solution, because there is no number that is less than -1 and greater than 2 at the same time.